Hello, this video is for the IXL activity titled Relations, Convert Between Tables, Graphs, Mappings, and List of Points. The three-character code for this activity is Romeo Bravo Golf. At the time of this recording, this activity can be found at A1.Q.1. All right, so relations. What are relations? Well, we're going to get into talking about functions later on, but right now we're just talking about relations. Things we need to know about are domain and range. We understand that our domain is pretty much our x values, and range is our y values. Also, whenever we talk about domain, we are talking about inputs, and our y values, also known as our range, well, these are our outputs. So we're talking about domain and range, x values, y values, and inputs and outputs, and we match all of those up. So domain is your x values. Your x values are also your outputs. Your range, well, that's all your y values, and your y values are also your outputs. So it says to express the relation below as a graph. Well, this is what we call a mapping right here. So we do have a mapping. We're going from a mapping, and we want to convert it over to a graph. So we look at our domain, or all of our x values. We look at our range and all of our y values. We can see with these green arrows here, it's letting us know which domain element is matched up with the range element. Another way to say that is what x value is matched up with what y value. So let's go ahead and graph that. Get our pen here. And we see that 1 is mapped to 8. So let's go where x equals 1. It's right here, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I'm not going to fill these in all the time, just kind of so we understand the spacing there. 0, all our y values. 0, 1, 2, 3, 4, 5. Oh, wait a second. 1, 2, 3, 4. Yeah, here we go. 4 to 5 to 6 to 7 to 8 to 9 to 10. All right. So let's go ahead and where x is 1, which is right here. And we want to go up to where y has a value of 8. So that's going to be right there. So let's go ahead and plot 8 there. So we took care of 1 mapped to 8. Now let's look at 6 being mapped to 3. Find the value of x is 6 here. Let's follow that up till we match up with 3 over here. So 6, 3 is going to be right there. And we'll go ahead, click there and map that one. And then finally, we have 9. X value of 9 is mapped to a y value of 9. So here's where x is 9. Here's where y is 9, where the two of those meet. Where is that? Right about there. So we'll go ahead and plot that point there. And at that point, we have 3 inputs, 3 outputs, and we have 3 points on the graph. So we're probably good to go. Let's look at the next one. Looks like we're going from a table to mapping. It says, look at this table. Here we have 6 mapped to 17, 6 with 14 are also ordered pairs. Real quick, like talking about ordered pairs. Ordered pairs are an x value and a y value separated by a comma and contained inside of parentheses. We see some ordered pairs over here in the next problem, don't we? So in this case, whenever I say that our x value is 6 and that's mapped to a y value of 14, you also realize I'm talking about a domain. Our domain is 6 and it's mapped to over in the range to 17. So however you want to interchangeably use that whole idea of domain, x input, and then the other side of it is all of our y values, which is our range and also our outputs. So we have an input of 6 and an output of 17, an input of 6 and output of 14, an input of 7 and output of 6, and an input of 2 and an output of 14. So let's see. 2 is mapped to 14. Yep, that looks good. 6 is mapped to both 14 and 17. 6 mapped to 14, 6 mapped to 17. So far, so good. And 7 mapped to 6. 7 indeed matches up with 6. So I'm pretty sure it's the first one. So no need to check the second one. If you really want to, you can check it. It's the incorrect answer. Express the relationship or the relation. I always want to throw a relationship in there. Express the relation below as a set of ordered pairs. So here we go, ordered pairs, an x value, a y value separated by a comma contained inside of parentheses, right? So the x values always come first. That's why they're called ordered pairs, because order matters. The x value comes first, just like in the alphabet. X comes before y. So wherever we see 13, and we have a blank here, well, 13 looks like it's mapped to 17. So we'll fill in 17 here. And then for the other one, something's mapped to 14 right there, and that appears to be 11. So let's put 11 in here. Let's check out the third ordered pair here. Is 6 mapped to 20? Yes, 6 is mapped to 20. And what is mapped to 6? It looks like 5 is mapped to 6. So we'll fill in 5, and that is our final answer for this one. Looking at the next one, which mapping diagram represents this relation? So we're going to look at the graph over here, and then we're going to find the matching map. All right. So let's look at -5. I got this -5, and it's supposed to be mapped to +1, +2. So -5 on the x-axis right here is right here. And mapped to -5 is a y value of 1 and a y value of 2. Sure enough, good to go right there. Now where x is 2, our domain right here, we should have outputs of 1 and -3. Here's 1, here's -3. So it looks like our first choice is the correct choice. Now we could go ahead and double check that second answer. Let's see. -5 mapped to, -5 is mapped to 3 things. Well, -5 is mapped to -3, 1, and 2. Well, we see at -5, there's only 2 points here, right? So we know the second one would be incorrect. Next slide, fill in all the blanks. So we have here a table, and we have here a graph. We need to take the information on the graph and fill in the table. So I always like to start with the lower values and work my way from the left side of the graph, going along with all my x values over to the right, working my way from left to right. So first one I come to is -3. -3 seems to be matched up with +1. So let's fill that in. -3 is matched up with +1. So -3, +1. Look at the next one. I see a point up here, so that's going to match up with -2. -2 is the input. The output appears to be +5, so 2, 5 is one of them. Not possible, it is one of them. And then where x is 0, there's like 1, 2, 3 inputs for 0. Whenever x is 0, we get what? -1, -2, and -3. So let's go ahead and fill those in. 0 for -1, 0 for -2, and 0 for -3. So that should leave us with nothing but the one they gave us of 2, 4, where x is 2, y indeed is 4. So this point right there is this spot in the table right there. On the next one, we have a map, and we need to take the information from the mapping and put it onto the graph. So let's go ahead and do that. -10 is mapped to positive or -1. So -10, map that to -1. There we go, right there. And then -4, map it to 9. -4 is here. And we're going to map that to 9, which is up here. So that should be that spot right there. Let's go ahead and map -4, 9, right there. Next one, going down, it's -2, and we're going to map that to -8. Here's -2, and here's -8 here, so it would be this spot right there. -2, -8. Click on there and put that one in. -1 is mapped to 6. Here's -1. Here's +6. So that would be that spot right there. -1, 6. And then we have, where's my highlighter there? We have 0, and it's mapped to -8. So let's go where x is 0, go down to -8, so it'd be right there on the y-axis. Anytime that your x value is equal to 0, your point is going to be someplace on the y-axis. If the x value is 0, it's on the y-axis. If the y value is 0, then it's going to be on the x-axis. And then 1 is mapped to 0. So where x is, well, see, there's a good example right there. Y is going to be 0. So it'll be on the x-axis. So let's find where 1 is right there. And the y value right at this point, well, the y value is 0. So that would be that point there. Plot that one in. And just to double check, I have 1, 2, 3, 4, 5, 6 places. Inputs, 1, 1, 2, 3, 4, 5, 6. Yep, got them all. Here we're going to fill in the blanks on a table, and we're going to fill in those blanks on the table from the information we see in the graph. Again, I like to work from the left and work my way to the right. So that's -4, so that's -2, so this has got to be -5, right? So I'm going to have what looks like 2. -5 is going to produce 2 separate y values, or another way to say that is that -5 has 2 separate outputs. Those outputs are -2, and this would be here would be -5. So -2 and -5. -2 and -5. Now we see that -5, right down here where y is -5, has 3 separate outputs, right? And I'm going to have to change something up. Here's the -5, 1, 2, 3 outputs. One of those is -4. So all these -5s, I need to put in these spaces here. So let's back up. One of those -5s has an input of a -5 there. So -5, -5, which means we can get rid of this one right there. Doubled it up. And then I guess the other one's going to be, no, not -2. It's going to be -4, -4, 5. So this one here, let's mark these. This one here, number 1, -4, -5, that would be number 1. -5, -5, that's going to be what this one here, number 2, right? Call that 2. And then the other -5, oh, is whatever the x value is 2. See it right up here? So let's go ahead. I'm going to erase this. Take care of that. That would be 0.3 right there. That's my third one. So I have 2 more to go. So let's see. Whenever I have an input of -5 here, I'm going to output a -2. Let's go -5, -2. And then up here, I know this is what's known as the first quadrant. Over here is quadrant 1. This is quadrant 2. I know you go like the opposite direction of what you would think. This is quadrant 3, and this is quadrant 4. And I know that up in quadrant 1, that whenever anything's in quadrant 1, both the x value and the y value are both positive. That I do know, so I should have 2 positive numbers. And x is 2, y is 5, so I would have the 0.25. That would be right there. So let's go ahead to 5, and there's the solution for this problem. On the next one, express the relationship below is a set of ordered pair. So I have a table, and I need to go to ordered pairs. Looks like most of them are filled in. Let's check them off as we go. So, let's find the ones. -6, 12. -6 is mapped to -12. So I went ahead and took care of that one. -8 to +8. That must be this one here, right? -8 to +8. Let's try it out. -16 to 15. -16, 15, right there. So I got that one. And 17, -15. That one's the first one up here. -18, 8. -18, 8. There we see the second one. And then we have 14, and it has an output of 8. So it looks like we got them all. Look at the set of ordered pairs that we have here. Here's all of our ordered pairs, 1, 2, 3, 4, 5 of them. Let's go ahead and see which mapping works. Well, notice we got 4 inputs here and 3 inputs here. We have 5 ordered pairs. So we must have some inputs having more than one output. So let's go ahead and try this out. -20 is here, and it's also here. Notice that, -20 and -20. It has 2 outputs, -20 and 12. So here's -20. It's mapped to -20, and it's also mapped to +12. We're good to go at that point. What about 0 to 12? 0 mapped to 12? Indeed it is. 4 mapped to 12? 4 is also mapped to 12. And then finally, what about 2 to -7? 2 to -7. It looks like the first option is the correct option. So I'm not even going to take my time to check the second one. And on this one here, I believe this might be my last question. Hold on. And no, it is not the last question. So I want to go from a table to a graph. So our inputs are -10 or +10. So here's +10 right here. It's mapped to +8. So we want to point right there. Stick one right there. And then on the next input is -6, and we get an output of 8. So -6 and 8. Looks like that would be right there. So -6, 8. Click right there. Next input is -7. It has an output of -4. So -7 and -4. So that should be our mark right there. -7, -4. Click on that. And input of -6, output of +9. Input -6, output +9 right here. So that looks like it's going to be that right there. -6 and +9. And then finally, input of -5, output -4. Input -5, output -4. So it looks like it's going to be right there. -5, -4. Outstanding. On this one here, we have ordered pairs. Where's my highlighter? There it is. We have 1, 2, 3, 4, 5, 6 different ordered pairs. X value, Y value, separated by comma, contains side of parentheses. Ordered pair. Because order matters, X comes first. So let's see. Remember our first number is X value, the input. The second number is the Y value. That's the output. So I have an input of -9, output of 3. Input -9, output 3. This one's already taken care of, right? So we'll check that one off. Input of +4, output +4. Oh, it's going to be in quadrant 1. I know because they're both positive. Input 4, output of 3. That would be right there. So I've taken care of both of those are done. -1. Well, actually, how many ordered pairs? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. We still need to find the other one. So -1 is supposed to produce a +3. Oh, there we go, right there. At -1, +3. So now I should have 1, 2, 3, 4, 5, 6. We'll count them up. 1, 2, 3, 4, 5, 6 points, and 1, 2, 3, 4, 5, 6 ordered pairs in the set. The brackets on the end, those represent that they are indeed a set. And these are my last two questions here. So let's see, we're going to look at the table and we're going to find the matching map. Input of 14, input of 14, and input of 14. Wow. So 14 has 3 separate outputs. That we input 14 and we get back a -7, a -8, and -15. So let's find positive 14. Look, this 14 only has 2 outputs, -15 and -7. So let's go to the second map, 14, and that's map 2. This one here, I'm going to go ahead and highlight these. And 14 is map 2, -7, -8, and -15. And we can see that -7, -8, -15 indeed are the ones that 14's map to. However, in the first mapping, 14 only had 2 outputs, that being -7 and -15. So I know that the second answer is the correct answer. And then finally, on the last one, we have 1, 2, 3, 4, 5 ordered pairs. So we should have 5 points on our graph when we're done. So let's start going through those inputs and outputs. Remember, the first one is your X value, that's your input. The second number is your Y value, that is your output. So we're going to have an input of -1 and an output -6. We'll click there. That takes care of the first one. Input of +5, output of 1. They're both positive, so I know it's in the first quadrant, so I mark that one off. -2, 5, so -2, +5. I'm going to click there. Takes care of that. 9, -2, so input of 9's down here. Go down to the output of -2. Put that one in there. Good to go. And finally, an input of 9 again, and it's going to produce this time a -3. So we go ahead and click that one right there. And 1, 2, 3, 4, 5 elements in the set. 1, 2, 3, 4, 5 elements on our graph. So those are all of my examples for the activity relations, convert between tables, graphs, mappings, and list of points. Now, go level up your learning.